Hello friends, so today I am going to discuss about Corey-Winter reaction. It is mainly sometimes also known as Corey-Winter olefin synthesis because in the final product olefin is formed. So here is the reagents, which is carbon and sulfur containing compound, in which carbon is working as a electrophile, and here both living groups are Cl or any CDI type of living group can also be used. And in the last stage there is a use of phosphorus containing compound, and this reagent will be used as the removal of sulfur and final product will be gate. So here is the main reactant is 1,2 diol, and mainly here these other group which are attached with the carbon containing alcohol is not matter, because both OH should be in the same side, not and these other group does not involve in main reaction, so their importance is not so much required. But both OH, means to say 1,2 diol, both OH should be in the same side for proceeding reaction. So here start with this reaction, as normally the substitution reaction type of kind of reaction will proceed here. And here OH is working as a nucleophile, and it will attack on electrophile of carbon, and after the charge separate after the charge formation and removal of chlorine will proceed, and there is a formation of positive charge on oxygen because it is sharing its lone pair with electrophilic carbon, and in the final step the proton will remove after taking its positive charge. And in this process going ahead, same kind of reaction will again happen with this OH group which is participating in this reaction and giving its lone pair to the carbon compound which is acting as a electrophile, and finally we will get this result. And in second step, or we can call it as a last step, the phosphorus containing compound role is being played, and its lone pair will attack on sulfur, and finally it will remove sulfur because it likely to be with sulfur, and we may say that sulfur is having a empty d orbital, and it basically rely on maximum electron containing compound, and here the carbon is very less electron containing compound, and that's why sulfur go towards the phosphorus side, and it removes from its place, and it forms S double bond P OMe whole 3. Here Me is a methyl group, and finally we will get a carbene because sulfur is removed from its place, and finally it will convert it into carbene. Carbene here is carbon here is a electron deficient kind of intermediate. And finally here another POMe whole 3 attack on a carbene because it is electron deficient, and formation of negative charge will occur on carbon and positive charge on phosphorus, because phosphorus is giving its lone pair and sharing its electron to with carbene. And finally the bond will break. Here it is a monoxide type of thing, I don't know sorry. So here the ring will break, negative charge will attack on oxygen and formation of double bond here, and this bond will cleave, and here the formation of double bond, and this bond will cleave, and here not formation of double bond, but this negative charge will go on the oxygen. And finally what will we get, as it is a simple CS3 bond, and it will finally form alkene, and this kind of product will form. So finally what will happen, it is not so much stable compound. For its stability, the negative charge will attack on carbon, and removal of POMe whole 3 will occur. And finally what will we get, POMe whole 3 plus CO2. As I have told you before that POMe whole 3 will work as a removal participant of sulfur or other type of or other groups such as CO2. And finally what will we get, alkene, CO2 and sulfur containing POMe whole 3 from this place where carbene formation was happening. So this is a Corey-Winter reaction, and it was asked in NET December 2019. So stay